Everyone. We are excited to present our project titled Farm Assistant, developed as a part of our class Applications of Artificial Intelligence. Our team consists of myself, Anusha, Haripriya, Karthik, Rajshri, Srilekha. This was a collaborative effort where each member contributed to different aspects of design, development, and testing. For the problem, we thought of pharmacies, which frequently face operational bottlenecks, especially when it comes to interpreting the handwritten prescriptions by the doctors. These documents often lead to delays, human errors, or even dispensing the wrong medicine in the wrong amount. On top of that, the inventory checks are still largely manual in many places, which can be both time consuming and prone to human mistakes. To address these issues, we designed an end-to-end AI solution that automates the interpretation of prescriptions and checks medicine availability. We use the Gemini LLM for OCR and structured extraction, and then LangGraph combined with tool calling for seamless text to SQL translation, eliminating the need for manual queries. So here's a quick breakdown of our system architecture and workflow. The user interface is built using Gradio, which allows the user to upload a prescription image. Once uploaded, the Gemini LLM processes the image and extract key structured details like drug name and quantity. This structured data is then passed to LangGraph, which invokes a tool call that automatically queries our SQLite inventory database. So no manual code or no SQL writing is required. The database checks availability, parses the request, and sends a validation response. And then finally, the Gradio interface displays a clear success or failure message back to the user, making the process seamless and intuitive. This architecture reduces both human workload and the potential for human errors in the pharmacy workflow.
Hello everyone. I will walk you through the key features and backend design of our pharmacy assistant system. Let's begin with our core features. So we use Gemini Flash for high context understanding and accurate reading of handwritten prescriptions. It helps us extract medicine names, dosages, and instructions with strong reasoning capability. We also apply prompt engineering to clean and structure this extracted text using chain of thought prompting. This ensures consistent formatting across different prescription styles. Next, we use for different prescription styles, we handle that via repeated testing and prescription with fine tuning prompts. We also automate SQL generation using LangChain tool calling to communicate and update SQLite DB dynamically. Next slide, please. Yes. So our database is designed with two main tables. One is drugs and sales. Drugs has the drug ID, name, and quantity in stock, and sales has the drugs which are sold and what was the quantity sold. We have built predefined SQL utility functions to ensure safe updates and schema introspection to support future scalability. This is a simple one-to-one relation, one-to-many relationship. Oh, next slide, please. Uh, so this is a simple one-to-many relationship table that we have simulated. One drug can have multiple sale records. The table references the drug ID from the drugs table. With this setup, the assistant can check if a drug is in stock using ID or name, auto update the inventory after a sale, and provide either a summary view or detailed info on a drug when asked. That concludes the system overview, and I will pass it on to Sri Lekha to take on from here.
For the deployment setup, we used environmental variables like API keys. For example, we use Gemini Vision and pass to SQLite database. This keeps like best practices for AI system security. We use requirement.txt for the for the reproducibility, ensuring it would be easy for the end users, and it also supports local production and production deployment. This dual setup allows faster iteration during development and easy access to end users. For the secure and repeatable configuration, it promotes fast onboarding for the new team members and collaborators, reduces deployment issues, defining clear configuration rules and defaults. So my teammate Karthik will ensure do the demo of this project.
Hey everyone, I'll walk you through the demo of our application. So we have the URL for the demo over here. Once we click on that, we'll be redirected to this UI interface that we have created, which takes the input in a form of file upload. So this is a test image I'm going to use for the demo purpose. So once I click on upload, it loads the image, and after upload, it takes some time to process the handwritten prescription, and you can see that the Gemini agent has read whatever the drugs are available from the image, and you can see the frequencies and the duration also been extracted from the image, and the required quantity is basically the product of frequency per days and the number of duration. So it's a product of them, and we get the result over here. Once we get the required quantity, this required quantity initially queries with the DB to check if that particular drug is available in our inventory or not. If it's available, it's going to show us a tick mark, and if it's not available, it's going to show us a cross mark. Once we can see that the drugs are available, then we can go down to the pharmacy actions, where we can select any particular drug we want to sell. For this example, I'm going to select Zofar. Suppose I want to sell Zofar. I'm going to select Zofar, the drug, and click on cell selected drug. Once I click on this, the DB automatically gets updated via the agent, and we can see that a transaction has been recorded for Zofar, and it also shows us the remaining stock available in our DB. And here is a like comprehensive view of our the total inventory, like how many quantities are left over here. And let's imagine a case where we want to sell multiple drugs in a single prescription. So I can simply just go to other drugs. Suppose let's imagine I want to sell this Andile over here. Then if I click on sell drug, it will sell that particular drug and enter the sales transaction into the sales DB, and it automatically updates the inventory over here. That's it from me, guys. This is the demo of our app. Thank you.
Yeah, hi everyone. Um, while working on this project, like we faced several real world challenges that we listed here. Firstly, TR OCR, it works well in the terms of converting the handwritten to text, but the output was in the structured format, so which made it harder to extract the meaningful data. And secondly, Gemini Vision was more accurate, but the formatting kept changing, which meant we couldn't rely on it directly. Also, the result we got varied a lot depending upon how the prompts were worded. Even the small changes made a big difference. Another tricky part was validating the frequency and the duration fields, especially when the values were handwritten in a different styles. Sometimes GPT generated SQL queries with uh, that didn't make sense. So we had to carefully guide it. Lastly, keeping the language model consistent in its response was a challenge across different use cases. Next slide. Here is the evaluation strategy. To make sure our model system works well, we followed a proper evaluation process. Firstly, we tested with a different real world handwritten samples to check how well the OCR tools were performing for the important fields like drug name, dosage, and the frequency. We manually compared the outputs to see how the accurate the model predictions were getting. We also ran control tests, so how the system handled the difficult or unusual inputs like unclear writing or any missing data. Throughout this project, we used agent logs in LangGraph to trace the flow step by step. That helped us to identify exactly like where the system was failing and how to fix those parts. Overall, this strategy helped us to improve the accuracy and the reliability at each and every stage. Next, Rajeshri will continue. Thank you.
Hi, here is the future work. For future work, we enhancements that include multi-language and branded prescription support, a real-time monitoring dashboard, a role-based access, mobile and web extensions, and integration with a large scalable databases. Next is for the references. To build and evaluate our solution, we refer to a range of technical resources. The AWS blog on Gen AI based text to the SQL was instrumental in guiding our tool calling pipeline using Gemini and LangGraph, especially to secure and dynamically SQL query generation. For training and testing our OCR model, we use datasets like an IAM handwriting database and a Kaggle dataset of illegal medical prescriptions. These sources gave us access to real world messy handwriting samples that help us fine tune prompt engineering and test model. Together, these references provided the foundation for both the technical architecture and practical implementation of our project. Thank you.